अच्छा बच्चों, we have to quickly recap, review, revise the chapter on summation of series. ठीक है? अच्छा, I would be relating this with your O-level mathematics. ठीक है? Now, can you tell me that if there is a sequence like 3, comma 5, comma 7, comma let's say 9, and so on. Can you tell me what is the nth term for this series, for the sequence, in fact? Yes,
2n plus 1.
very good. So this is going up to 2n plus 1. Okay. If we put the plus signs between them, so this turns into a series. Okay. So this is going up to 2n plus 1. We do need sometimes the sum of the, let's say, the first 5 terms or for the first 10 terms. You have seen that this is also called an arithmetic series, okay? You have seen that there are the formulas for the sum of, if you just see that the Sn is n over 2 into 2a plus. Do you remember this formula? You have studied this in your A-level mathematics, okay? So you have to basically sum this up, okay? So in AP, there was a formula for this. And in this further mathematics, we have altogether a different kind of notation over here, okay? So we call this, summation R from, for example, if you have to find the sum of the first 10 terms, okay? So you will be doing it like this 10 over 2 into this 2 into 3 plus 9 times the common difference, which is going to be 2. So that is how you will be doing this in your A-level mathematics. But here it's written like this, sum of the series from R1 to 10, okay? And then here you write this 2n plus 1. So you need to really understand that what do we mean by this when you're finding the summation of a series. So is it clear that why do we call this the summation of a series over here? Okay, so this is the kind of series over here. So like we have these formulas over here through which we find the summation of the series up to I mean a required number. Okay, now like this is an AP over here, or this is a linear, like its nth term is linear. Let me see if you people can really tell me. This can be a bit harder. Okay. Mm, Let me make that mentally quickly. For example, you have there is 6, comma 12, comma 20, comma 30, and so on. Can someone tell me what is the nth term for this? And then I change this into a series: 6 plus 12 plus 20 plus 30, and so on. Hmm? You think about its nth term, I'm going to write the next one for you. It can be, yes, and then this is 24 plus 60 plus 120 and plus so on. Yes. Okay, I'm not going to tell you that how to find the nth term for this, but you will have to believe me that its nth term is n plus 1 into n plus 2, okay? Or this is going to be n squared plus 3n plus 2. Okay, so like you will not be always be having a linear kind of a series, like a series whose nth term is linear. So you see that if you have a sequence over here which follows this quadratic like its nth term is a quadratic expression. So for example, you need to find the sum of the first 10 terms of this expression. So that would be written as n square plus 3n plus 2. Okay. And similarly, this one was, by the way, it was a cubic. I just wrote them mentally very quickly. So this was actually n into n plus 1 into n plus 2. Okay. So this nth term was basically n cube plus 3n squared plus 2n. Okay. So if you want to find the sum of this series from R1 to, let's say, maybe 100, yes. So this would be written as n cube plus 3n squared plus 2n. Okay. So we have the formulas here to find the sum of these series, and these formulas are different for the linear ones, for the cubic ones, and then for the constants even. Okay. So let me tell you quickly, briefly, and you guys will help me how to find, how to write down those formulas. These formulas, by the way, they are given in your formula booklet as well. Okay. Um, this one was the linear situation here. Then next one was quadratic, and then this was the cubic one. Okay, there can be cases when you can have a sequence like this. For example, you can have let's say uh, 4, 4, 4, and so on. So what will be its nth term, Bacho? If it is 4, 4, 4, and so on, what will be the nth term? Hmm? That
4n.
that will be 4. Okay. So suppose if you want to find the, let's say, r from 1 to 10, and this is just 4. So wouldn't that mean this is going to be 4 times 10, Hannah? Yes. So that would be 40. Okay. Now make me recall these formulas. Like for example, this is from R1 to N, and you have just R over here. So what is the nth term? Sorry, what is the sum of the series for a linear one, which is just R over here? Yes. What was that?
Rn.
Mhm. Yes.
R
Kn.
into
Yes. Yes. I'm hearing. I'm listening.
It's just
Hmm? Okay. You have
Rn.
R from 1 to N, and from R for R square. And then you must know these formulas by heart, Bacho. So
for
this,
r it's half bracket n plus 1.
yeah, this is half into n into n plus 1. Okay. Who was that?
R.
Who was that mathematician which was who, like, the teacher wanted to engage the students. So I think he had to go somewhere. So he asked them to, okay, find the sum of the numbers from 1 to 100. Mhm. So you see, what is the nth term for this?
100.
The nth term for this. Hmm? Like this goes on up beyond 100 as well. That is R. That is R. First term is 1, the second term is 2, the 100th term is 100, the nth term would be n. Okay. So, how did that smart boy find the sum of all these values? He just paired them, like this is 1 plus 2 plus 3 plus so on. Then there is 98 plus 99 plus 100. So he gave the answer within a minute or less, even less than that. He told his teacher that, look, sir, there are 50 such pairs which have a sum of 101. Hmm? There are 50s. What do you say? Like, what is 1 plus 100? That is 101. What is 2 plus 99? That is That is
101.
101.
101.
101.
Yeah. So this is going to be 50 times 50, sorry, 50 times 101. Okay. So if you, can you relate it with this rule over here? Hmm? If you're going to find this from 1 to 100, so isn't it like 1 over 2 times 100 times 100 plus 1? Does it relate to this? Yes, Bachu?
Yes, sir.
Hannah? So I'm just going to give you, just wanted to give you the reason that why this is so. So similarly, you can also prove that for this. So what is the formula for this sigma r square?
1 over
1
6
over
bracket n into n plus 1 into 2n plus 1.
Okay, and this is 2n plus 1. And then for the last one,
1 over 4 into n square into n plus 1 whole square.
I think that is a square of this. Like, if you square this, you get this one. Okay. So 1 over 4 into n square into n plus 1 whole square. Okay. So if you want to find this, you should split this into, like this is going to be 2 sigma r from 1 to 10 n plus r from 1 to 10, and there's just a 1 over here. Okay. And similarly, you can split this up into sigma r from 1 to 10, and this is your n square or r square. Okay. This should be r in fact here. Okay. And then you change that with the n at the end. Okay, so this is going to be r square. You have to bring this coefficient out of the sigma sign here. Okay, r from 1 to 10, this is r, and you can write it like this is r from 1 to 10, and you have 2 over here. So then you have to apply all these formulas over here. Okay, let me do one of them for you, and then you can go on to the exercise. Okay, let me make some space here. Okay, so for example, let's do this one here. Now this one. So this would be, first of all, you would say this is going to be r from 1 to 10. So what was the formula for the r from 1 to n r square? That was 1 over 6 into n plus 1 into 2n plus 1. Yes? Yes, Bacho?
Yes.
Anna? So I would be writing it as 1 over 6. My n is 10 now, into 10 into 11 into 21 plus 3 times the sigma r from 1 to n for r was half n into n plus. You must write them again and again so that you can learn them by heart. Okay, plus 3 times 1 over 2 into 10 into 11. And for the last one, this is simply 2 times 10. So by using the calculator or like, doing this mentally, you can find this up like this. Okay. And for this one, this would be the sum for a cubic uh, series is going to be 1 over 4 into n square into n plus 1 whole square. Okay, so this would be 1 over 4 into 100 square into 101 square plus 3 into 1 over 6 into 100 into 101 into 201, and finally plus 2 into 1 over 2 into 100 into 101. That is how you find the sum of the series, if it is just a constant or a linear, a quadratic, or a cubic one. Okay, so that is the first half of this chapter's revision. So you can try this first, and then we can go to the second half. Okay, if you look at the questions of this exercise over here, so it says show that the sum of this. So if I can quickly show you how to do this, so you would be saying, okay, this is going to be 3 times sigma r from 1 to n, and this is r, and then you can split this like this, r from 1 to n, and then this is going to be 5, okay? And then you have 3 into half into n plus 1, and then you have for this you have 5n, and then you simplify this, you take whatever LCM, whatever you do, you see that this is going to be n over, like, first of all, this is going to be 3n over 2 into n plus 1 minus 5n. You have n common over here, okay? And I'm taking LCM as well. So we are left with 3n plus 3, and you will be left with 10 over here minus 10, okay? So this is n over 2 into 3n minus 7. That is how you can show that this is like this, okay? And if you look at this fifth question over here, it says without using a calculator, find the simplified expression for all of this. So this is 1 square plus 2 square minus 3 square plus 4 square. So you can have a sequence. You can split this, like, focus onto this 1 square. Then you have the 4 square, and then you will have a 7 square over here, okay? Then you have this 2 square, this 4 square, sorry, 5 square, then you will have 8 square, and then this one, okay, 3 minus 3 square, and then minus. So these are basically three different sequences over here. What is the nth term for 1 comma 4 comma 7, so on? Yes, wouldn't this be 3n minus 2? Yes, क्यों भाई?
Yes.
And when you have squares on it, so this would be 3n minus 2 whole square. So that is how you're getting this one over here, okay? And then you have 2 comma 5 comma 8, so on. So its nth term is going to be 3n minus 1. And since there are squares on it, so you will have square on it. And for the last one, you can take a minus common from here, or even you can just let it be minus 3, minus 6, and so on, okay? So there are squares on it. So this is basically minus 3n. So this is going to be minus 3n square. Okay? So you will be applying these summation formulas onto it. Basically, you have to simplify this. Okay? After applying these kinds of formulas onto it. Okay? Let's move on to the next part.